Hey Talia, it's Bo, and I am going to explain, I think in general, how to do row echelon form. The template, the pattern for this is pretty much uniform. In other words, what I'm about to do, you can do on any of these problems. And so watch me go step by step through this problem. First step, I want to get the first of my row echelon form rows having a coefficient of x of 1. So that's easy to do. I'm going to take the first equation, divide everything by 3. And that's going to get me I really don't care about any of the details in this. I just want to do it and get done with it. The second thing I'm going to do is get an equation that doesn't have x in it so that I can then divide by the coefficient of y and get my y, have no x, and have my y coefficient be 1. Easy way to get rid of x right there I'm going to subtract the first equation from the second equation. It doesn't really matter, but it makes my coefficients more positive. I have less negative numbers to mess with. So subtracting the first equation from the second equation there, I am going to get Now, I'm not loving that. Well, I am. But one reason I'm not totally in love with that is because this equation doesn't have a coefficient of y equal to 1. So I'm going to divide everything by 2. Now I'm going to go ahead in this methodology. I'm going to go ahead and rewrite the second equation as y plus 2z equals negative 1/2. Now, I haven't used the third equation yet, which is this one. I always have to make sure to use all the information given to me in the original statement of the problem. And I want to do, and this is important, I want another equation I guess I'll put in parentheses my third, with these two being the first two. I want a third equation with only y and z. Because once I've done that, I'm guaranteed that I can I'd have two equations with y and z. I would be able to combine those two equations, eliminate y, and have an equation with just z in it, which I would then solve for z, and I would then be able to have my third equation down here, z equals blah. It's going to take 2 steps to do that, I think. I'm going to take it really, a lot of this stuff doesn't really matter because I think it's more about just getting through the process. I'm going to take this equation and this equation. Now I will have used equation 3. I'm going to eliminate x, so I won't have an x in it. I'll have only y and z, and I'll have y and z in this equation. I'll have y and z in this equation. So I'm going to multiply the first equation by positive 5. Again, I don't really care about the details, but I can see that I'll have more positive coefficients. I'm going to multiply this by negative 3. Oy, oy, oy. We'll see what happens. I'm going to multiply the top equation by 5, and I'm going to get 15x plus 15y plus 25z equals 5. And I'm going to multiply the third equation by 3 and get negative 3 and get negative 15x minus 27y. Now I'll probably box something up here and then we'll be back to where we always are with boxed up stuff. But I hope not. I should have done it the other way around, which is probably what I originally said. But in any case, I'm going to multiply 17z by negative 3, and I'm going to get negative 51z. So I got a whole bunch of negative numbers here, which is what I said I wasn't going to do. When I add those together, I get negative 12y minus 26z equals 5, which is the same as 12y plus 26z equals negative 5. Not that that matters, but it just makes stuff more positive. I'm going to take this equation, which included the third equation here, and I'm going to write it here, and then we'll see what I do next. Let's review where we are. Simple first step, get the x coefficient to be 1. Simple second step, get the y coefficient to be 1. Now I have these two equations with y and z, and I'm going to combine them in such a way that I can get rid of y. I'm going to take 12 times, let me see where I am here. I'm going to multiply this by negative 12 and add it to this, and I guess I'll be careful about this. So I multiplied by negative 12. And then I am going to add this equation with this equation. In the nuttiness of all this, I am going to rewrite this. I'm going to rewrite this. I'm going to add this, and I'll have an equation with just z in it. Now I am adding this, and I get I think I botched something. I'm adding the, no, wait. I'm taking negative 12 times this, and that's giving me 6 minus 5 is 1. So that's giving me negative 12 times this gives me negative 12y and positive 12y, negative 24z and 26z, which gives me 2z. And here I get, when I multiply by negative 12, I get 6 minus 5 is 1. So, z equals 1/2. And then I kind of ran it. Well, then let's do this, Thalia. It's hard to do this. I'm not very good at it. Equation number 1, equation number 2, equation number 3. I might be running out of time. I have a little time limit on these things, but let's review what I did. 3 equations, just wrote down the original ones. Solve one of them, the one that looks most simple. Solve for x. Not solve for x, but where you have a coefficient of 1. Get rid of x, combining 2 of the equations. I did that here, combining equations 1 and 2, I got rid of x, and had an equation with just y. I can always divide that coefficient, so I get a coefficient of 1 for y and no x, and then create a third equation that doesn't have x in it, so it just has y and z. Now I have 2 equations with y and z. I can solve that for z, and then I get my third equation down here, or down here, where I've solved for z. I hope that helps you, Thalia, and I hope all this fits into my video, and I'll talk to you later. Okay, bye.